Hello guys and welcome to this tutorial. Now, if you are an anime fan, of course you will recognize this effect here. Yes, it's the Kamui. So in this video we're going to learn how to make it. Let's get into it. First of all, we need to create a new project, 3D URP or 3D URP with the sample scene. It's the same thing. Call it Kamui and hit create project. Wait for the project to be created. Now we have a few things that we would like to import, so go to the package manager, go to my assets, all skies. This asset is free, import it, and let's wait for it. Also we will import another package, Battle Wizard. This one here is also free, so import it. And we'll start by setting up our scene. So go to Window, Rendering, Lighting, go to Environment tab, and select a darker sky, something like this. Yeah, like that, that's fine. Now, how are we going to make this effect? This effect is pretty simple. Just create a quad, and the effect will be applied to this quad. You'll see it's one-sided, so we'll make it rendered from both sides. Let's create a materials folder, materials, and we will create a shader, create shader graph. And if you don't have this visible here, it's because there was an error in importing the URP package. You see down here that the package is not imported properly, so we'll fix that here. Go to the package manager, go to Unity repository and search for universal. Remove it and install it again. That's an error that may happen if you have an older version of Unity. Wait for it to compile and everything should be fine. Now that that's fixed, let's remove this quad and create it again. Here, 3D object and create another quad. Now everything is working fine. Create shader graph, URP, and omelet shader graph. Let's call it Kamui. What are we going to do here is that we're going to make this quad not transparent, but it will take a texture containing the colors of what's behind it. Like it's transparent, but it's not. First of all, we need to come here, make the surface type transparent. It doesn't mean that it's actually transparent. And render face to both. Now, how to do that is that we need a scene. First, before the screen position, we need a scene color node. Assign it here. And if we save this, go back here, create the material, press M to create the material, and let's call it Kamui 2. Assign it here. And to get this to work, we need to go to the settings folder, select these URP assets here, not this one, these three, and make sure you enable depth texture and opaque texture. Now you see it's almost not transparent, but it's like it is transparent. It's actually creating a texture for it. That's what's exactly behind it. Go back to the shader here, and we need a screen position node. We need also something to rotate, so search for a rotate node, and we're going to rotate a twirl node. Look for twirl. A twirl is basically a spiral. You see nothing is being applied here because we need to insert a value here in this rotation value. So Let's create a time node. Whenever you want to animate anything in shader graph, you need always a time node. Search for multiply, and we will multiply it by speed. Let's go here to the blackboard and create a float, call it speed. Bring it here, and like that. Let's give it a default value of 1, and link it here. Now it's starting to rotate. Let's arrange things a little bit. In order to apply the effect, you need to rotate a noise. A simple noise will be fine here, and assign it to the UVs. Now you see it's starting to rotate. We need also another float to control the noise scale, so call it scale. Assign it here, and another one called strength to control the strength of the twirl. The strength here is how many circles are there in the spiral. Give it a default value of something like 10 and 50 for the scale here. This will be fine. Now in order to apply this, we need to lerp it. So lerp here. If we lerp these two values, what does this mean? It means if I create a float here, let's call it distortion, and it has to be between 0 and 1, so make it a slider, and it's here between 0 and 1, drag it, assign this value here. Now if I change the default value from 0 to 1, 1 is completely this texture here, and 0 is this texture here, so it blends between them. Give it a default value of 0.1 for now. Let's assign this here, save this, and go back here. You see we have this faint little effect. We need to make it a little bit more intense, and we'll make it a circle because this is a square here. In order to do that, I've prepared a texture, so let's import it. I'll link it in the description. Import this here. Change its property in the inspector to sprite 2D, and we don't want compression on this. Hit apply, go back to the shader, bring this here. Let's reduce the preview. We won't need this distortion value, and the blend will be the alpha of this texture. Now you see we have a nice fade out effect. Also, we want it to be linked to this alpha value here. Save this and go back. Now you see we have this interesting effect. Next, let's go to the wizards folder. Look for the SRP folder. Open the URP package. Unzip it. Select yes to all because I have it already unzipped. Now select all the folders that came out and put them in the wizard folder here. It will replace the old ones, or add one to the name actually. So go to the prefabs one, select one of these characters. It won't work like that because you need first to delete the materials, prefabs, the shaders, the scenes, and the textures. Now re-import them and go to the prefabs folder. Now you see we have this character here. There it is. Let's make it look the other side actually. So reset the transform first and rotate it 180 degrees on the y-axis. Hit F to focus on it. Let's hide these gizmos. Select the Kamui from here, the squad, and hit Ctrl Shift F to bring it to your view position. Let's bring it somewhere around here in front of his eye. And you notice that it's actually casting shadows. We don't want that. It's supposed to be transparent. So go here and check cast shadow. Save this. Position it where you feel it's right. Somewhere around here. Let's make it bigger. Something like 3. Yeah, that's fine. You can keep the z-axis at any value you want because this is just a quad, it has no depth. And we want to change a little properties here in the material. So I tried a few values and I found that scale of 6, scale of 50 and strength of 8 give a nice effect here. Let's make it to always refresh here so it won't stop rotating. We get a better preview like that. Next, to apply the effect as I showed in the intro, we will create a script. So create a folder, call it scripts, go inside and create a C# script, call it Kamui. Now it's okay if you don't know how to script, this script is pretty simple. Open it. So this script here has start method and update method. The start method is executed only once when the object is first started, and the update method will execute every frame. So this script will be assigned to the character, so it needs a reference to the Kamui. Make a serialized field, make it private, and if type transform, call it Kamui. Now in the update method, actually we don't need this method here. I wanted to apply the effect or disappear or appear whenever I press space. So if input dot get key down key code dot space, so whenever I press space, this effect here will be applied and it will be in a coroutine. A coroutine, you can think of it something like a thread. So start coroutine and let's call it show Kamui. Let's create it. Here, a coroutine is always of type enumerator. And call it show Kamui. It takes no parameters. What this going to do is it's going to lerp between two values of the scale. So vector3 initial scale is the Kamui dot local scale, and the target scale will be 3. So vector3 dot 1, so this gives us a vector of 1 1 1 multiplied by 3. Next we will need a float for the lerp value. Let's call it time and initialize it at 0. And while time is not 1, we will enter this loop. So in every iteration, time plus equals time dot delta time. What this does is that it gives us the elapsed time since the last frame, and we will multiply it by a speed value. Let's create it here. We want it to be serialized too, so serialize field, float, and call it speed. Now, whenever the time value exceeds 1, we will set it to 1. And we will apply the lerp now. So Kamui dot local scale equals vector3 dot lerp, and this actually does the same thing that we did in the shader graph. So a lerp node always takes two values and a float to lerp between them. The first value will be the initial scale, second value will be the target scale, and the lerp value will be the time. Next, we want this to wait until the next frame. So yield return. We use this syntax in the enumerators to wait for new wait and wait for end of frame here. Next, we will need to keep track whether our player is visible or not. So let's create a boolean for that. Private bool, and let's call it is visible, and it will be initialized at true. Now, depending on that, if is visible, if it's already visible, we will hide it, and we will hide the Kamui too. So these also will be created in a coroutine. Start coroutine. Let's call it hide character, and another one to hide the Kamui. It'll be almost the same thing as this. So let's create them. Enumerator hide character. It has no parameters, and we will copy pretty much everything here. Just we will change these. So the initial scale is transform.local scale, and we want to multiply this by 3, and here we're going to change the transform.local scale. We will do the same thing for the Kamui too. Let's duplicate this and call it hide Kamui. Here it will be hidden. Oh yeah, in the hide we want to hide it and make the scale 0 to hide it. Like that, and change this to Kamui and this back to Kamui too. And the last coroutine that we will create is to show the character. So here, else, if the player is not visible, we will show it. Start coroutine, show character, and it takes no parameters. Also, we will hide the Kamui. Paste this here, and it will be the same as this. Let's call this show character. So the initial scale will be the current scale, and the target will be vector3.1, and that's it. Now let's fix the name here, show character. Now we want a little delay between these two, and between these two, so the Kamui effect will be visible for a little time before it disappears. We do that with like this, yield return a new wait 4 seconds, and we will give it a delay variable that we will declare in a minute. Same here, and let's create it. We will serialize this one too. So serialize field, private float delay, and let's go back to Unity. Go back to the scene view, wait for it to compile, and we will assign this script to the character here. So this is our character. Let's assign this script and let's assign this reference. The speed will be something like 1 and the delay will be 1, just for testing now. Let's start with the Kamui being hidden, so let's give it a scale of 0 and let's run the game. I press space, it's being shown, and as you see the player is being scaled down but in the wrong direction. So this is fixed with a very simple fix. So here, create an empty object, let's call it origin, put it roughly in the eye position of the player, somewhere around here. Now parent the player to this, like that. Remove this script from here and we will assign it to the origin. 1 speed, 1 delay, and we will assign the Kamui here. Run the game again, and if I press space, you see it's working right. But the effect is a little bit weird, but that's because we need to rotate the player to give it a more an effect that looks more like the anime, the actual Kamui. I noticed that we actually haven't changed this value here, so is visible equals not is visible. So if it's true it becomes false and vice versa. Now to change the rotation we need to lerp it to, so transform dot rotation equals, it's not a vector 3, it's actually a quaternion, so quaternion dot euler. This will allow us to use xyz values for the angles, and the x and y will be 0, and we will lerp on the z value, so math.f mathf.lerp. This will lerp the z value between 0, 360 degrees, and with time as the lerp value. We will copy this and do the same when showing the character to. And actually I want different speeds for the character and the Kamui when being displayed, so let's change this, Ctrl RR to refactor it. So let's call this Kamui speed. This here is used so that the Unity inspector does not lose the previous value that we have serialized, and we will create another one, serialize field, private, float, and let's call this character speed. Go here whenever we show and hide the character and change this to character speed here and also here. Now we are pretty much done. Let's go back to Unity, wait for it to compile. Let's change the values here. I've experimented actually with a few values and I found that 2 for the Kamui speed, 0.8 for the player speed, and 1.4 for the delay work pretty fine. So let's run the game. Now press space, you see it's working great, and if I press it again the player appears. You can change the distortion value in the material, so let's go to the material here, change it to something you feel right. So let's change this to 10, change this to 70, anything that you like. Hit space again and you see it will be changed. Set this to 10 and look for a value that you like. Now I hope you liked this video. We'll make other cool effects in the next videos. If you have any questions, put them in the comments. We'll be glad to answer them. And don't forget to hit the subscribe button if you like this. And see you next time.